So this presentation will be about the seasons played and the points scored in NBA seasons and how the points scored and the seasons played are related. So first of all, we got the background information. So mostly about the sport. Basketball is one of the biggest sports in the world and the largest league of them all. The NBA has most of the best players in the world. There are a few exceptions who train nonstop all year round, and using data already provided by basketball tracking websites, we found the years played and how many points these players scored in those years. This can be used to help determine the prime age, where players start to decline, and where their physical capabilities reach IQ and where the best spot is. This topic is only really important for a few careers like athletes, doctors, physiotherapists. They would benefit from this data because when training, it's important to know when and where our players' bodies, their athletic ability will start to decline and when the player's IQ becomes more of a factor. For physiotherapists, it can help identify which problems an athlete they need to work on, like either endurance or maximizing potential while they still can, or how long it could take to recover for an injury, or if it's even beatable or not. Researching this topic can also help society by determining the point where not just athletes at this point, but like general people, where their athletic ability starts to decline from their prime, and when you can see that their mind really starts to improve and understand more, and how quickly it takes for people to pick up certain skills. So these are the variables. The first independent variable is the number of seasons played in the NBA. The first dependent variable, which is Y1, is the number of points scored during a player's regular season. And then the second dependent variable is the number of points scored during a player's playoff career. And then the linking variable used was the players' names and just the players. So first we're going to talk about the dependent variables. So as you can see here, the top histogram is for number of points scored in the regular season, and then the bottom one is number of points scored in the playoffs. So the median for points scored in the regular season among the 32 data sets was 12,831, while the mean was 12,678. So this is a good use to show median would be the average, where outliers don't have as big of an impact, and mean is where they do have a pretty large impact. So this can help us show that the outliers didn't have too big of an effect on the actual data. And then the standard deviation was 8,748.56, which isn't bad. It shows that most of the players were relatively close in points, but we can notice that the frequency of people scoring between 8,000 and 16,000 was the most, which makes sense because that's where, since the average seasons played in this was about 7.5, about 1,000 points scored per season is relatively average. And then number of points scored in the playoffs, the median was 573.5, and the mean was 1,430. So using that, we can see that the outliers had a huge impact. As you can see on the histogram, it's over half the players are between 0 and 1,600 points, and there are very few after that, with 4,800 to 6,400 and 6,400 up. There was only one player in each of those categories. And the standard deviation was 1,730, with looking at the histogram is quite a lot. It's over, the frequency, most people are below 1,600, and since the standard deviation is already higher than that, the players were very spread out in their playoff points. And then the box and whisker plot, the top one was regular season points scored, and the bottom one was the playoff season points scored. This shows that both of them had two outliers for each. However, the playoff seasons were much further outside the interquartile range for the playoffs, and the regular season, the whiskers extend a lot further than the playoff season points scored, which is interesting because you would think that the playoff season's points scored would be a lot closer since people don't get as much opportunity. But I guess since there's so many people at 0, the whisker below, is very small, where since there's nobody at 0 points scored in the regular season, there's nobody below the number. And then the two variables. So this was the scatter plot, which showed the trends of how many points are scored based on seasons played. And as we can see, both lines of best fit are increasing, which is good because it shows that they were correlated and that the more seasons played, usually you'll score more points. However, there are a few times where obviously players, they play more seasons and they don't score more points. And then the correlation coefficients for the regular season was 0.955, which means it was very correlated, and almost 100% of the time, when somebody plays more seasons, they will score more points. However, in the playoffs, it was only 0.74, which shows that it was pretty correlated, like usually, but some of the time people wouldn't. Like you can even see once you get to the 8th season, there's still people with 0 points scored. However, in the 6th or 4th, you can see people have scored more than people who played 8. Even 12, there's somebody with almost 0 at 12 seasons played. And then the correlation, as I just said, playoff points to seasons played has a moderate correlation, while regular season points to seasons played has a strong correlation. So in conclusion, it's pretty obvious to tell that this data is pretty related, which is pretty obvious in the end because obviously if you play more seasons, you're going to have more opportunities to shoot, you're going to have more time played, you're obviously going to have more points. However, it's not as correlated as I thought, because in the end, you'd think it'd be almost a direct correlation, but there were a lot of people who played much more seasons who didn't have as many points.